Hi, Mrs. Murat with your Unit 6, Lesson 1 practice problems. This is pages 9 and 10, and you're just doing numbers 1 through 4. All right, so today's lesson was all about a ladybug on a circle and then finding coordinates on a circle. So to get started, number 1, here's a clock face for each time given. Name the number the second hand points at. Sorry, so there's 30, that would be 60 seconds in a minute. And so all of these amounts of seconds would be out of 60. So 15 seconds after 1 o'clock would be a quarter of the way or 1/4 of the way around the clock. So at 15 seconds after 1 o'clock, the second hand would point to the 3. At 30 seconds after 1 o'clock, that's halfway. So the second hand would point to the 6. In 1 minute, it would be back up to the 12. And in 5 minutes, it would also be back up to the 12. So it goes a full rotation in every minute. All right. Number 2, at 2:15, the end of the minute hand of a clock is 8 feet above the ground. At 12:30, it is 6.5 feet off the ground. How long is the minute hand of the clock and how high is the clock above the ground? So let's see here. Let's draw in some things. So we're going to use this clock up here. So I'm only going to draw the minute hand. At 12:15, the end of the minute hand of a clock is 8 feet above the ground. So at 12:15, let's see, this would be like the middle of the clock. The minute hand at 12:15 is going to point at the 3. And at that time, it's 8 feet above the ground. So here, like wherever the ground is, this is a distance of 8 feet. Okay? And then at 12:30, it is 6.5 feet off the ground. So 12:30, the minute hand's going to be pointing at the 6. And now, so this height is for this point right here. This height at this point right here, let's say that's the end of the minute hand. The distance from there to the ground is 6.5 feet. So how long is the minute hand? Well, the minute hand is going to be the difference between 8 and 6.5. So since 8 minus 6.5 is 1.5, the minute hand is 1.5 feet. All right, so again, let's say the ground is here. And so this distance is 6.5 feet. This is 8 feet. So the minute hand would be the difference. Okay, what's needed to add to 6.5 to get to 8, 1.5. How high is the clock above the ground? Well, the middle of the clock would be the same height as it is right as like the end of the minute hand here. Okay, so the middle of the clock, or center, is 8 feet above the ground. All right. Okay, so number 3, we're looking at some equations for circles. And so the general equation for a circle is going to be using the center of the circle. And so the center of the circle is 0, 0. So that means we can start our equation with x minus 0 squared plus y minus 0 squared equals the radius squared. Okay? And so since x minus 0 is x and y minus 0 is y, I know it has to do with x squared plus y squared equals the radius squared. So all we have to do to figure out the correct multiple choice answer, it's either going to be B or C. It won't be A and it won't be D because neither of those have the x squared plus y squared part. So we just have to figure out the radius. And so to figure out the radius, I'm going to take this point that's on the circle. This is what I'm looking for. And using the coordinate 6, 8, I know this distance here, which is this leg of this right triangle, is 6. And then the height, the y coordinate, is 8. So using the Pythagorean theorem, I can say, okay, r squared is equal to 6 squared plus 8 squared. Excuse me. So 6 squared is 36 and 8 squared is 64. And when you add those together, you get 100. So the radius is 10, but we need r squared in the equation. So the correct answer is answer C. Since r squared is 100, this is the equation for that circle. All right, and number 4. So number 4 says the point 3, 4 is on a circle centered at 0, 0. Which of these points lie on the circle? Select all that apply. So if you think about points on a circle, so what we know so far, there's the center of the circle. 3, 4, I'm just going to estimate, so I'm going to kind of put some axes here, and then estimate 3, 4 maybe is about right here. Okay. And so thinking about this as a right triangle, we can figure out the radius. And so the radius of that circle, since this leg is 3, the x coordinate, and this leg is 4, the y coordinate, again, just using the Pythagorean theorem, the radius squared is equal to 3 squared plus 4 squared. And 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So the radius of the circle is the square root of 25, which is 5. And so if you think of, okay, these x, y coordinates, they have to work in this equation. The a squared plus b squared equals c squared. So if we know our radius is 5, then we can say, okay, if I square each of the coordinates and add them together, do I get 25? So negative 3 squared is 9, negative 4 squared is 16, and 9 plus 16 is 25. So A is a yes. For B, same idea. 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So that's a yes. For C, 0 squared is 0, 5 squared is 25, and 0 plus 25 is 25, so yes. D, 0 squared plus 0 squared is 0, not 25, so this is a no. And then E, negative 5 squared is 25. 0 squared is 0. When you add them together, you get 25, so E is also a yes. All right, so again, the strategy to solve this problem was to find the radius, and so any point on this circle should work in this like right triangle idea. And so we found 4 different points actually that would be on that circle. Also, you can think of parts C and E. If the radius of the circle is 5, then we can say, oh, this point out here is at 5, 0. This one up here is at 0, 5. Over here, this is at -5, 0. And down here, this is at 0, -5. Again, I know those 4 points for sure because the radius of the circle is 5. All right, so that is the end of your assignment. I hope the video was helpful.